These are homework solutions, lesson 5-2, fall 2012, Bologna High School Pre-Calculus class, logarithmic and exponential equations. We start by solving the following equations. We're going to give the exact answer in exact form and the answer in a decimal approximation when it's appropriate. To start, we change the exponential equation into logarithmic form. So we get log base 3 of 27 equals 5x. Recall that log base 3 of 27 is the exponent that we raise the base to get what's inside. So 3 to what power equals 27? 3 to the third power is 27, so log base 3 of 27 is 3. So 3 equals 5x. We divide by 3, or divide by both sides by 5 to get x equals 3/5. As a decimal, 3/5 is equal to 0.6. So there's the answer to number 1. Similarly, in number 2, we changed the exponential equation to logarithmic form to get log base 2 of 16 equals 3t minus 2. We ask ourselves 2 to what power equals 16? That's the fourth power, so 4 equals 3t minus 2. We add 2 to both sides, get 6 equals 3t, divide both sides by 3, and get 2 equals t. Because that is exact form and a decimal, written as a decimal, it's the same. There's no reason to give a decimal approximation. On number 3, we convert to logarithmic form to get log base 5 of 125 equals 2x plus 7. Log base 5 of 125, again, the power of 5 that gives 125 is 3. So log base 5 of 125 is 3 equals 2x plus 7. Subtract 7 from both sides to get negative 4 equals 2x. Divide both sides by 2 to get x equals negative 2. Again, no decimal approximation needed. Number 4, we write in logarithmic form log base 27 of 9 equals 4t minus 5. Now, to find the power of 27 that gives 9, that's a little more difficult. So that is exact form. We're going to leave it. We're going to solve for t by adding 5 to both sides. Get log base 27 of 9 and plus 5 equals 4t. Divide both sides by 4. We get log base 27 of 9 plus 5 divided by 4 equals t. That's in exact form. To change that, we're going to use the change of base formula and evaluate on our calculator log base 27 of 9 as ln 9 divided by ln 27. Then we're going to add 5 after we close parentheses, hit enter, then divide by 4, and our decimal approximation according to the calculator becomes t is approximately equal to 1.416 or 1.417 depending on whether we round or chop. I'll take either answer. Number 5, similarly, convert to logarithmic form. We get log base 36 of 6 equals x minus 5. Log base 36 of 6 is the exponent you raise 36 to get 6. So 36 to what power equals 6? Because the square root of 36 is 6, the square root is the same as the 1/2 power. So 36 to the 1/2 power is equal to 6. So 36 log base 36 of 6 is the same as 1/2 or 0.5. To solve this, we add 5 to both sides, and we'll get 5.5 or 11/2 as the exact answer and the decimal approximation. So on number 6, we treat the same. We do log base 81 of 27 equals 2t plus 3. Again, it's a little difficult to figure out what power of 81 gives 27, so we're going to leave it in that form. We're going to subtract 3 from both sides. Then we're going to divide both sides by 2. That's the answer in exact form. Again, in the calculator, to evaluate log base 81 of 27, we do ln 27 close parentheses divided by ln 81 close parentheses. Now we subtract 3, hit enter, and then divide by 2, and we get negative 1.125 for t. That's our exact answer and our decimal. In this case, it's exact. Number 7, we're going to treat similarly. We change to logarithmic form and we get log base 4 of 5 equals 5x minus 1. It's not easy to find the power of 4 to give 5, so we leave that in exact form. Log base 4 of 5, add 1 to both sides. Divide both sides by 5. That's x in its exact form. To evaluate this and get a decimal approximation on the calculator, log base 4 of 5, we do ln 5 divided by ln 4, close parentheses, plus 1, enter, divide that by 5, and our decimal approximation is 0.432. And our exact answer on our decimal approximation. We do 8 the same way, convert to logarithmic form, get log base 12 of 5 equals 2t plus 3. Subtract 3 from both sides. Log base 12 of 5 minus 3 equals 2t. Divide both sides by 2. Log base 12 of 5 minus 3 divided by 2 equals t. That's our exact answer. We evaluate using the calculator. Log base 12 of 5 is ln 5, close parentheses, divided by ln 12, close parentheses. Then we subtract 3 to get the numerator, hit enter, then divide by 2, and we get negative 1.176 is our decimal approximation. Number 9. Again, convert to logarithmic form. Log base 9 of 18 is equal to 10x minus 3. Add 3 to both sides. Log base 9 of 18 plus 3 equals 10x. Divide both sides by 10. We get log base 9 of 18 plus 3 divided by 10 equals x. That's our exact form answer. Now we evaluate log base 9 of 18 as ln 18, close parentheses, divided by ln 9, close parentheses, plus 3, enter, then divide by 10. Our decimal approximation is 0.431 or 2, depending on whether or not you round or chop. Number 10, we convert to logarithmic form. Remember, log base e is ln, so we have ln 3 equals 4t plus 1. Now we subtract 1 from both sides. Divide by 4. And our exact answer is ln 3 minus 1 divided by 4. When we enter this in the calculator, be sure that you do ln 3, then close parentheses, minus 1, enter, then divide that by 4, hit enter, and our approximation is 0.024 or 0.025, depending on whether you round or chop. Once again, we convert 11 to logarithmic form. ln 7 equals 2 minus 5t. Subtract 2 from both sides, get ln 7 minus 2 equals negative 5t. Divide by negative 5, and we get ln 7 minus 2 over negative 5 equals t. That's our exact form answer. Plug in a calculator, we do ln 7, close parentheses, minus 2, enter, so we get the numerator, then divide that by negative 5, and our decimal approximation is 0.010 or 0.011, depending on whether we round or chop. 12, we convert to logarithmic form to get ln of 10 equals 7 minus 4x. Now we're going to subtract 7 from both sides. ln 10 minus 7 equals negative 4x. Divide by negative 4, we get ln 10 minus 7 over negative 4 equals x. That's our exact form. Evaluate in the calculator. ln 10, close parentheses, minus 7, enter, divide by negative 4, and x is approximately equal to 1.174. That's our decimal approximation. On number 13, before we can convert to logarithmic form, we need to get the exponential term by itself. So we subtract 4 from both sides and get 2 to the 5 minus 3t equals 12. Now we convert to logarithmic form and we get log base 2 of 12 equals 5 minus 3t. Again, this is one that we can't easily figure out, so that's exact form. We leave it. We subtract 5 from both sides and then divide both sides by negative 3. That's our exact form answer. Now, to evaluate in the calculator, log base 2 of 12 is ln 12, close parentheses, divided by ln 2, close parentheses, minus 5, hit enter, then divide by -3, and enter again, and our decimal approximation is 0.4716, or, 0.471 or 0.472, depending on whether or not we round or chop. Number 14, again, we must first get the exponential term by itself, so we subtract 24 from both sides. We get e to the 10 minus 7x equals 1. Change this to logarithmic form. We get ln 1 equals 10 minus 7x. ln 1 is simply 0. So 0 is 10 minus 7x. Add 7x to both sides and divide by 7. We get x equals 10 sevenths. As a decimal, that would be 1.428 or 1.429, depending on whether or not you rounded or chopped. We're going to do the same thing for number 5. We get the exponential term by itself. We add 15 to both sides to get 7 raised to the x minus 7 equals 14. Change to logarithmic form. Get log base 7 of 14 equals x minus 7. Add 7 to both sides and get log base 7 of 14 plus 7 equals x. That's our exact answer. Now, to evaluate in the calculator, log base 7 of 14 is ln 14, close parentheses, divided by ln 7, close parentheses. Then we add 7, hit enter, and our decimal approximation is 8.356. That's part 1 of the homework solutions for 5-2.